Example 1b, we have the integral of dx over 2 plus 9x squared. Now, as we did before, I want to remind you that we have these three options up top. We have number 1, which is arc sine, number 2, which is arc tangent, and number 3, which is arc secant. And our job is to try to match the structure of what's given to one of these three options. So I'm looking at this one and I notice that there is no radical sign, and it seems like this is the only one that does not have a radical sign. So I'm thinking it's going to be that. Now I have a squared plus u squared. Well, I see that plus sign, and I am going to rewrite this, and I'm going to rewrite this so that it fits this structure. So y equals the integral of dx of something squared plus something squared. Let's start with the 9x squared. 3x. If we let u equal 3x, 3x squared is going to give me 9x squared. Now let's look at the number that has to go here. I'm trying to take something, square it, and make it equal to 2. That would be square root of 2. So now we have identified our a and our u. Now remember, this problem, it's given in terms of x's. There's a dx right here. We are trying to change it into a problem that's in terms of u. So don't forget that you have to use u substitution. So when I do that, I'm going to let u equal 3x. I'm going to take the derivative du dx. That's going to be 3. And as you know, du is equal to 3 times dx. And I only need to replace dx. So that 3, I need to get rid of it. So I'm going to divide both sides by 3. And my substitution is going to be 1/3 du equals dx. So when I do that, I'm going to put the 1/3 up front. And I have this du, and then square root of 2 squared plus 3x squared. All right, so that now fits exactly what we have up here. And so now let's write the answer out using this part. So it equals 1/3 times 1 over a, our a is root 2, times arc tan of u, which is 3x, over a, which is root 2, plus c. And this is what we were looking for. You could, if you wanted to, instead of having both of these terms, you could write it like this. That would be fine.